Forecast busts. We hate them as meteorologists, and I'm sure you all hate them more, trying to get weather information from all of us. So, what goes into these forecast busts slash what causes them to happen? This is the art of the bust, and another episode in our PNW Weather 101 series. I'm meteorologist Tanner Leach bringing you this featurette. So, first off, before I go into the reasons, let's define what a major forecast bust is. A major forecast bust is when almost everything forecasted about the event goes wrong, which means it could go in the positive direction, which I'm defining as whether that is more extreme than forecasted, or negative, extreme weather forecasted didn't happen. And what isn't a bust? Well, that's just any given in things within quote unquote standard margins of error when it comes to temperatures, like being 103 degrees instead of 100. It was a little bit less or a little bit more than the typical margin of error of snow forecasts because, especially in the Pacific Northwest, snow forecasts are very finicky, to put it lightly. And this is before factoring in for microclimates. Also included in this is the snow slash liquid line was 20 miles off forecast. 20 miles is actually pretty good. The average margin of error is a little bit less than that. I believe it's about 15 miles an hour area, but but still, if that 20 miles is, for instance, forecasting a line from McMinnville to Aurora, and that line ends up being 20 miles north, you're suddenly at the Columbia River. So that would mean a lot of people are suddenly in freezing rain rather than snow in that case, even though the setup was correct. Also, slight risk of severe thunderstorms, but all the warnings were concentrated in one area region. This actually is pretty common for the Cascades when we get slight risks of severe weather. They tend to be concentrated in the Cascades, but it's listed as the Portland National Weather Service. Its office shows a slight risk of thunderstorms for part of their area of responsibility. So that can create communication issues from meteorologists, including myself, to the general public. You got less rain than forecasted, but 3/4 of an inch is still plenty of rain compared to like an inch to two forecasted. Also, you can translate that to lower. Wind gusts were a little bit off forecast, but it was still a windy day, and something shows beyond 3 or 5 days out, depending on the pattern and confidence of that, and the opposite happens. Really, anything beyond 5 days out is what I like to call clown range because, quite frankly, the air goes up significantly after 5 days out for any quote unquote climatological pattern, which is stuff we tend to see, like your typical rain storms, versus more complex pattern. And I would say anything beyond 3 days is more clown range for that because how much can change with those. So, for the forecast bust since 2002, there's been a significant chunk. But some of the more notable ones here are the December 2009 Portland traffic nightmare snowstorm and the double bust in 2016, one of the positive direction that caused the Manzanita tornado and another tornado plus eight other tornado warnings on the Oregon coast. And 2 days later, the Columbus Day repeat that never happened. And this is just the first half. I've had even more since then, including in the jet skis are doing donuts on Highway 34 flood. I think that this was the only bust from the River Forecast Center because they've done a really good job predicting flooding especially with the smaller rivers. However, that one was a different setup and far later in the year than usual. The most recent bust as of recording this video in May of 2025 was a severe thunderstorm outbreak that didn't end up happening. Also, major busts can be enhanced with hype surrounding it, as is the case with with three of these busts. And then just so you know that these are consensus forecast based busts, for most of these forecast busts, there have been a few meteorologists that have disagreed and ended up getting it correct, including myself with the February 2023 snowstorm as an example. One theme you'll notice with this is that a lot of these forecast busts tend to either be severe thunderstorm outbreaks or snowstorms. And there's a few exceptions to that, but that's because as reasons we will see in the upcoming slides here. So, reason number one is the coastal radar gap. The Oregon Coast Radar Gap prevents knowledge of incoming storms, including their structure and moisture content. Primarily affects windstorms, severe thunderstorms, and the moisture content of system. So one thing I will notice that was a direct bust due to the coastal radar gap is the South Valley surprise of 2002. So in blue is the radar from 10,000 feet and below, above ground level. The darker orange is 6,000 feet and the yellow color 3,000 feet. The track of the South Valley surprise goes pretty close to what this red line is, and it wasn't until after landfall that we got any sort of radar indication of this storm. If that made landfall further north, it would fall under the Washington coastal radar's range, and as a result, Seattle would have had a warning before it ended up doing anything. If it made landfall in this northern portion, or if it made landfall in the southern portion, Portland would get at least a small warning beforehand. Instead, no warning at all, which led to that forecast bust. On top of that, radar feeds higher resolution models, especially the HRRR model, which updates every hour as new radar data comes in. No radar data, you're going to get a less accurate forecast model, especially the convective producing one. This especially affects severe thunderstorm forecast busts. So these are the preventable busts if a Oregon coastal radar was built. I'm not saying that these busts would have gone away entirely, but they would have helped at least give some warning that it was going one way or the other. Most of these are severe thunderstorm based because they are more microclimate influenced, and then there's the January 2017 snowstorm. That one was a major bust because there was far more moisture content than predicted, on top of having microclimate interactions that models poorly forecast. So, reason number two is our quote unquote borderline climate, to use dramatic language. Most major busts involving severe thunderstorms or snowstorms, these happen to be the setups, or these happen to be the systems where you need very specific setups for them to occur in our region. The frequency of such events are far less than continental regions in the same latitude because you need continental patterns for our classic snowstorm setups, and you cannot have a pure onshore flow setup for severe thunderstorms. They either have to be coming out of the southwest for more of a warmer ocean than we tend to see with a pure westerly flow pattern, or you need it directly from the south for severe thunderstorms. If anything is even slightly off with these patterns, the entire event can fall apart for everyone, not just those seeing those slight changes, as we saw in March of 2025. All busts except for the flooding and windstorm busts can be directly traced to this reason. The third reason, I've alluded to this earlier in the video, is microclimates and terrain. Microclimates can cause wildly different conditions within a small area. Some of these microclimates, like the Chehalem Mountains, can also have downstream effects outside of the main zone. Downstream effects being defined as effects that go further beyond that microclimate, but can be directly traced back to that. So, the Chehalem Mountain Cold Air Dam would be an example, keeping cold air trapped in the Portland metro area for longer than it otherwise would. That's just one example. Forecast models also cannot resolve a majority of our microclimate. This also includes high resolution models. The absolute worst example I could find is that the American GFS model's ensembles showed the Portland airport at 550 feet in elevation rather than its actual 20 feet. This is a nightmare to try to do snow forecasts because you're essentially getting the snow forecast for 550 feet, and models in general show snow oh, as what is actually falling, not always what is sticking to the ground. So that makes it harder to interpret that when doing a snow forecast if we're basing it off of the forecast models. A lot of times we deviate from the models. Thunderstorms can be enhanced or hampered by terrain, which is half the reason why they are a little bit more common in the western foothills of the Cascades than they are in the Willamette Valley proper. Though the Portland metro area does average two more thunderstorm days than the Eugene metro area. However, Eugene tends to get more or prolific lightning from our summer nocturnal thunderstorms. This is because pop-up thunderstorms that we see in the springtime can get enhanced by some of our microclimates. And then also microclimates in our area are some of the least understood aspects increasing air. I have seen very few peer-reviewed studies on our microclimates that is not named the Columbia River Gorge outflow or things specifically in regards to wildfires or the Cascades itself. Three, one type of bust and two additional snowstorms I can directly trace to it being microclimate induced busts. That is pretty much every severe thunderstorm bust, the January 2017 snowstorm, and the February 2023 snowstorm. In all fairness, I could be downplaying the microclimate effects of others. I was also too young to remember or much before or the 2014 in year in general because I wasn't paying attention to every detail before then. So that's a different factor that needs to be said for a disclaimer. Reason number four, data scarcity. The ocean has a lack of data. The North Pacific Ocean in general does not have as many buoys as the tropical Pacific. And you could be wondering, well, there's a lot of buoys directly off the coast. That should increase his forecast value. Theoretically, yes. However, the classic windstorm path tends to follow something like this. A storm system tends to form somewhere in the north central Pacific. This normally is south of the Aleutian Islands, where you have a higher density of buoys that can read atmospheric data and get readings on these systems, at least at the surface level. And this low pressure system tends to travel east before starting to curve northwards as it rapidly intensifies before it hits the coast. A lot of windstorms that we get do not start rapidly intensifying until just before it hits the buoy patch. So if there's not enough information, that can increase the forecast error. And then on top of that, there's no upstream weather balloons. Upstream meaning since the prevailing flow pattern in the atmosphere is from west to east. If you launch a weather balloon in Salem here, that will show the atmospheric conditions above Salem, but you can trace it through the jet stream to say, okay, yeah, that could be coming towards other areas here. It's more common to do that in the Great Plains states because you don't have terrain inhibiting you with that. So, because of that, we only have atmospheric soundings for areas directly over us, nothing before. And then on top of that, for data scarcity, satellites can help, but they're far less accurate than direct observations. North Pacific also has less ship and air traffic than the North Atlantic. Then also, as a side note, oh, even for the events where we could see something like a severe thunderstorm outbreak, soundings are normally only done twice a day. They generally only added if severe thunderstorms are forecasted, where soundings become far more important than a standard forecast. And that's saying a lot because I'd argue weather balloon soundings are the most important piece for weather forecasts. Also, as a side note, these weather balloon launches get directly fed into pretty much every forecast model. There are no weather balloon launches that I'm aware of in the Pacific, so that also contributes to the lack of data as well, on top of the fact that the North Pacific sees less ship and air traffic than the North Atlantic, whether that's commercial or scientific. Pretty much every bust except for the April 2019 flooding bust can be traced, at least partially, to this reason. And then lastly, I will conclude with the hazards of forecast busts. Forecast busts decrease public confidence in meteorologists. Next time a threat happens, fewer people may listen, or some listen and just flat out think the opposite will happen. It also feeds the memes. The two ones I hear at least semi often are meteorologists are the only job where you could get it right 25% of the time and not be fired. To which I introduce to you politicians and lawyers. The other one is it only snows, for example, when they aren't forecasting it. There are numerous examples where this one is wrong, including the recent February 2025 snowstorm for most forecasters. And then, in case it wasn't clear, nothing feels worse to a meteorologist than getting it wrong. That goes in both ways because our number one job is to make sure you all are as safe and as prepared as possible. When we get it wrong, we are not doing our jobs properly. This is also why I like to do my verifications and showing what went wrong, even for a forecast that is mostly right, but there's a few aspects that are wrong. In our area, forecasts are rarely perfect. A future PNW Weather 101 episode will go further into why PNW weather forecasting is so difficult, which will rehash a lot of the points here. So, that is going to be it for this video. Let's hope the next severe weather event does a bust to make all of us look like idiots again, but if it happens, well, that's par for the course for the Pacific Northwest. So until then, stay safe out there, and until the next PNW Weather 101 episode, take care.